First one here.
Sorry?
I said you went from being the last one here to the first one here.
Yeah. I heard that's what it is, not being late.
Do we have stuff to pick up? Not sure. How long is Usually we have an hour before, so. What? A 10? A 10? Oh, no. That's this one. That's this one. Okay, then. Yeah. But we got like 14. He's doing it this. And when he told me about it, he got a 14. Some people got a 14. I'm just shocked. I got a 4 on speaking, a 4 on reading, and a 4 on writing, and then a 5 on listening. Good job. That's good. Oh, well, I know I didn't get the team pass because of now I want to see what you got. Oh, no. I was thinking, I joined the first question and I just submitted it before. See, and I did too. Oh, you did? Yes, for like 3 of the things. Well, because it was like the end of the test and like no one else was talking. I was like, I feel so awkward talking right now. So I was like, I just submitted it. In the beginning, I submitted like. Okay. I also didn't listen to any of them twice, and I think that's partially why I passed because it said like, yes, but it also said like, because I was reading, I'll show you the score thing. It was like, you have advanced understanding because you only need to listen to it once. So I was like, oh, the book was 50? Does that mean like,
why would they say why don't they just put that? Yes. Like people aren't gonna want it. It says L.
like I think you did better because I thought I failed.
Yeah, nice.
I started this year.
I don't know.
We were two people that got the answer for the elevator question.
Yeah.
And we said something.
Yeah, and everyone was like, no. I was like, no. All right.
I feel like I did pass by that wasn't.
I was talking like fast and thinking about it. Because I was like, I don't know how to like being like so like all
Did they feel good?
Well, I just said there's a different tactic when it goes into it. And it says it's super cool.
Well, I need to like I practiced. So like I'm like practicing. I mean, can I just see what y'all have?
Wait a minute.
That's okay. I
Good morning, MHS. Today is Thursday, October 26, 2023. Please join me in a minute of silence. Please stand if you are able and join me in the pledge. United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you, and have a great
Okay, we need 2 things to get started this morning. If you did not turn in that book assignment number 50 into Google Classroom, this will be your last chance to still get full credit on it. Make sure your name's on it and come give me your hard copy. Also, the handout we need to work with today is one I gave you last time and we just didn't have time to move on to it. So go in your binder, find number 51. It is notes over EVT and MVT, extreme value theorem and mean value theorem. Oh, I got it. Yeah, you got it. I'll check. Okay, no other homeworks? The rest are in Google Classroom? Okay. All right, so last time I was hoping that we could have started on this a little bit, but that's okay. So earlier this year, we talked about intermediate value theorem, which helps you find some of the y values in the middle. Intermediate kind of means middle. Extreme value theorem that we're going to talk about today is when we want to find the absolute biggest and smallest values, so the extreme values. And then mean value theorem is the mean is like average. Part of that theorem is about an average thing. So we're going to take those notes, and then we're going to practice some of this in Khan Academy. 2 of the Khan Academies will be from last class. First derivative test, so figuring out where a function is increasing or decreasing. And of course, if you can map out where it's increasing, decreasing, you should be able to note where there's relative max and mins. There'll be 1 on extreme value theorem and 2 on mean value theorem. 1 will be on finding a C value that will make sense to you after we do the notes, and 1 is on the justification, so explaining why it works. And this is it for the big 3 theorems in calculus: intermediate value theorem, extreme value theorem, and mean value theorem. So these all kind of get wrapped up together. We'll also talk about Rolle's theorem for just a second, but that's not one you need to study at all. I just want you to know the name. Okay, so if we are talking about maxes and mins of a function, last time we talked about relative maxes. So a relative max is if you're just looking at a small set of data, it's temporarily the biggest value. So there's a few different times where we have relative maxes. And then relative mins are the same idea, the smallest y value within a small set of data, like this or like this. What you need to understand is that some of these occur at something we talked about last time. Relative maxes and relative mins always occur at critical numbers. So not all critical numbers become relative maxes and mins, but all relative maxes and mins come from critical numbers. So that's why we needed to start talking about that last time. So what I need you to see from this picture tries to show a little bit of this, is down here there's a couple blanks. For the function showed above in the graph, we have relative maximums at x equals b and d. There's 2 times that we have relative maximums. We also have a relative minimum at x equals c. And a point like x equals e, notice this is not called a relative min because for it to be a min, it has to switch from decreasing to increasing. And if the graph doesn't exist to increase, then that's not good enough. Decreasing to increasing gives you relative mins. Increasing to decreasing gives you relative maxes. Yes?
And why is A a min?
A is an absolute min, not a relative min. To be a relative min, it has to switch from decreasing to increasing. Okay, but also in this picture, it basically is pointing out what extreme value theorem tries to simplify for us. So extreme value theorem tries to sum up, if you're interested in finding the extreme or the biggest, the global, whatever you want to call them, maxes and mins, there's 2 types of numbers you have to check. So this is considered a shortcut because without this you have to consider every x value, and if you don't know what the graph looks like, that's a tall order. But absolute maxes and mins can either occur at a critical number, like you can see is happening at D, or at an endpoint, like x equals a. Just a quick glance at this graph, you can see the biggest y value comes at x equals d, and the smallest y value comes at x equals a. Extreme value theorem says the only places that might be an absolute max or min are the critical numbers and the endpoints. Okay, so question 1 here. If you were asked, I'm going to change this up a little bit. It says identify relative and absolute extrema. Let's just do absolute extrema. We did the relative extrema last time. That's where you would do the little line chart, figure out where it's increasing, decreasing, so you can see relative max, relative min. You still need to practice that, but you'll get some of that out of the Khan Academy. Okay, so if I want to know the absolute extrema, so the absolute biggest y value and y value and min y value between 0 and 3, and I don't know what this looks like, and I don't want to take the time to graph it, and or I don't have a calculator to graph it, what extreme value theorem tells us is that the max and min are either going to occur at critical numbers or at endpoints. So, critical numbers are still the same as we talked about last time. Those are when the first derivative equals 0 or undefined. So you're going to have to take the first derivative, think about if it's undefined. That would be if you have any x's in your denominator. Otherwise, go about solving it like you normally would. But the critical numbers are likely to be relative maxes or mins, and a relative max and a relative min might be the absolute max or absolute min. This is what we see right here. This wasn't just a relative min, it was also the absolute max. Sorry, it wasn't just a relative max, it's also the absolute max. So we're going to test those two, and we should test the endpoints. We should test 0 and 3. Now, we don't really need to test 0 twice, but this is what extreme value theorem tells us. Just test the critical numbers and test the endpoints, and your biggest y value and your smallest y value will be in this list. Okay, this you guys need to highlight. Bless you. This is what's called a candidates test. Extreme value theorem is giving us some candidates for absolute max and min. What I have highlighted here, actually, I will be very specific. This that I have highlighted is called a candidates test, and you will need that for FRQs at some point in this year, and for sure on your AP exam. If you're asked to find absolute extrema, absolute max value, absolute min value, this is your justification. Without this, you're going to have to explain why you tested the x values you tested and why you didn't test the x values you didn't test. But this candidates test is sufficient for that. So if I want to know the y value when x equals 0, be careful not to plug that into the derivative. That would help me know if the graph is increasing or decreasing, which is good sometimes. But I want to know the value. So make sure you plug into the function. Plugging in -2 shouldn't be too bad, but I'm just going to do my calculator just to speed it up a little bit. Okay, this one is 4/3. This is 18. Okay, so notice this question doesn't say anything about extreme value theorem, but extreme value theorem told me I need to test the critical numbers 0 and -2 and test the endpoints 0 and 3. You don't need to test 0 twice. And this would show me the absolute maxes and mins. Now I can see the y values, so I can see the absolute min is 0, and sometimes you need to know when it occurs at x equals 0. But the y value is the value. And the absolute max is 18 because that's the biggest value. Absolute max is 18, and if you need to know when it occurs, say it occurs at x equals 3. But the absolute max is not 3. It occurs at x equals 3.
So you can just say the point, like absolute max occurs at 0.38.
You can say the absolute max occurs at 318, but usually the way the question's asked is what is the absolute max? And so your answer should just be 18. Or what is the absolute min, which is 0. Okay, so that is way better than having to try to graph this, especially if the graph was harder to figure out. It narrows it down to 3 points to check. And I think it's probably worth going ahead and looking at this as a graph so that you can see what we're doing here. Or see that it worked at least. Okay. That's what the function was. Is that correct? Okay. Okay, so if I graph this function, how come it looks like the absolute min would be negative infinity and the absolute max would be positive infinity?
Because you're only measuring it from 0 to 5.
Right, the question gave us bounds. We really only care about x equals 0 to x equals 3. So I'm going to change that in my graph. And now we can see the smallest y value is what?
0.
And the biggest value, oh, I got to go up a little higher. The biggest y value was what? Okay, so let me change this to 20 so we can actually see it. So smallest y value is 0, and when x equals 3, the biggest y value is 18. So we were able to figure out the smallest and biggest y values simply by testing the critical numbers and the endpoint, which is all that extreme value theorem says for us to do. Okay, let's do that one more time. So different function. Again, I'm not graphing it in the calculator. I don't want to graph it by hand. But if I need to know the biggest value or the smallest value, then extreme value theorem, you don't have to state it at all. But what extreme value theorem says is you should be testing critical numbers and the endpoints in the function. So the endpoints are going to be given to you, but the critical numbers we need to be able to find. So critical numbers are helpful for a lot of stuff. So as we talked about last class, bless you, the critical numbers will occur when the first derivative is 0 or undefined. So of course, the derivative is going to vary in difficulty. It could be product rule, quotient rule, chain rule, but that stuff should be getting easier and easier for you. But it looks like the only critical number was -1. So my absolute min on this graph is going to either occur at x equals -1, -2, or 3. And my absolute max will occur at either -1, -2, or 3. So these are the only 3 places I have to check. Now, again, be careful. We want to know the y values, so that's like a point, so we should be plugging into the function, not the derivative. So again, that's one that we can do by hand, but it's a little messier, so I'm just going to throw it in the calculator real fast. This comes out to be 0. When x is -2, the y value is -1. And when x is 3, the y value is 64. This that I'm highlighting is what's referred to as a candidates test. This is what your justification needs to be on an FRQ. Now, with all this in front of us, what is the absolute min? Zero is the smallest? -1. And sometimes you might need to know when it occurs. But the min value is -1. And what about the absolute max? 64, because it's the biggest one there. And you may need to know that it occurs at x equals 3, but usually not. That's significantly better, because extreme value theorem's basically telling you, hey, you don't need to test x equals 0, or x equals 1, or x equals 2.5, or x equals 1 1/4. It narrows this list down to 3 things for us, so that's pretty efficient. The absolute min is the smallest y value in that list. The absolute max is the biggest y value in that list. Okay, so again, you're going to practice one of the Khan Academies are question types like this. And again, just out of habit, start making your work look like this so you just naturally do it. It is by far the easiest way to do justification for an FRQ. But is there any immediate questions about extreme value theorem? Oh, I guess I should have said this too. This does matter. Extreme value theorem really only works if it's a continuous function. If your graph's jumping all over the place, then this is not necessarily true. It's got to be continuous, nice smooth graph. Okay, the other one, which, I don't know, extreme value theorem always shows up on an FRQ or 2. It's pretty heavily tested on the AP exam, but mean value theorem might be even more, because they like to do multiple choice and free response questions with mean value theorem. So, mean value theorem is a little pickier. It has to be continuous over the whole interval, including the endpoints, and it has to be differentiable on the open interval. So the continuous means it's not jumping around, there's no asymptotes, there's no holes, and the differentiable means it's a nice smooth graph, no sudden sharp turns, no cusp. We can take the derivative at any x value that we want to. Okay, what mean value theorem says is if your function is continuous between a to b and differentiable from a to b, then there's at least one time c is just some generic x value, where the instantaneous rate of change, bless you, which is derivative, is equal to the average rate of change, which is the slope formula. If it's continuous and differentiable, there's at least one x value that we're going to call c, where the derivative is equal to the average rate of change, slope. So this picture here is trying to show you that, and I'm going to try to color it the same way as that one. So, because you really need to understand what's going on here, because it'll help it stick a little bit. Okay, so from some generic a to b, this down here, this represents the average rate of change. That's like the slope formula. I don't care where it's at. All of these times, I care about where did it start, where did it end, and how much time did it take. And on average, I need to go up the same amount. But because this blue line would be our function, because he is continuous and differentiable between a and b, there's at least one time that we will call c, where the instantaneous rate of change, which is derivative, slope of the tangent line, is equal. So do you see how these slopes are the same? How they're parallel? That's all that means. The instantaneous rate of change derivative has to be equal to the average rate of change at least once. So sometimes, and one of your Khan Academies is going to ask you to seek out those values of c that make this true. So if it says use the mean value theorem, that means you're going to have to know that that is when the instantaneous rate of change equals the average rate of change instantaneous rate of change is derivative. So of course we're still, everything we're doing is derivative related. This you'd have to plug in the end y value. Again, we should be able to do this without a calculator, but I am using a calculator to just speed it up a touch. So plugging in 2 into that, we get -6. Minus plugging in -2 into the function gives me 2. So it's like it's ending at a y value of -6, and it started at a y value of +2. So it's going down 8 over 2 minus negative 2 is 4. So his average rate of change is negative 2. His instantaneous rate of change is his derivative. And so where these two things are equal, the mean value theorem guarantees me that this is going to happen at least once. But if we're asked to find C, figure out how big C is, again, C is the x value that makes this true, then we just need to finish solving this algebraically. We could subtract the 6 over, we could divide both sides by negative 6 and reduce our fraction, and then what? Okay, look good? Plus or minus. When you take the square root of both sides, you need plus or minus. So, mean value theorem only guaranteed that it was going to occur once, but for this one, it appears to have occurred twice. There's 2 times where the instantaneous rate of change is equal to the average rate of change. Now again, I think it's beneficial for you to see this, to see what we found. So let me sketch this real quick. Or not sketch, but graph. Okay, what were the x values in that question?
Negative 2 and 2.
Negative 2 to 2. Okay, so from negative 2 to 2, this is all that it had cared about. On the left side of our work, I can't flip back and forth, but you guys have this. The average rate of change only cares about where did you start, where did you end, and how fast did that occur. So that would be, actually, let me bump this up a little bit. Okay, so the right side of your equation, I guess I did that and I don't have purple here, but it's fine. All it cares about is what y value did you end up with, what y value did you start at, and how much time did that take. So on the right side of our work, we found that the average rate of change was negative 2. The left side of our work was the instantaneous rate of change, which is derivative, and then we solved and figured out where those occur. And one of them was the square root of 4/3, which is about 1.1. So at 1.1, at that instant, he is equal to the average rate of change. And then also, negative square root of 4/3, which would be about negative 1.1, which is about right here. At that instant, it also was equal to the average rate of change. So that's what we're finding. The average rate of change has to equal the instantaneous rate of change at least once. If it occurs more than once, that's great. The work's not any different, but mean value theorem guarantees that it happens at least once. Okay, so for mean value theorem to work, why is it important that it is continuous over AB? Well, you can word this however you'd like to, but to be continuous just ensures that it's not jumping around. So I would say something like discontinuous maybe jumping around. So, for example here, this is discontinuous. If I wanted to do like this point and this point, the average rate of change would be 0. I'm trying to make those flat so you can see it. But there's no time that the function equals 0. that jump messes up the whole thing. It's got to be continuous for mean value theorem to work. Also has to be differentiable. So the only way it's not differentiable is if you have asymptotes like this, or holes, or sharp cusp values. So to be differentiable just ensures, and again, you can word this however you want to, ensures no sharp turns. So I try to draw a picture. It's a little tough, but this would not be differentiable here. And if I tried to go from like, if I call this A and this B, the average rate of change would be 0. And so the slope goes from positive to negative. So normally that means that it's 0 somewhere in between. But because of this cusp, it's actually never 0. It switches from being positive to negative instantly. So there is no time where that holds up. But assuming that it is continuous over the closed interval, differentiable over the open interval, mean value theorem guarantees there's at least one time, maybe more, but at least once where the instantaneous rate of change is equal to the average rate of change. Okay, the next little section here, Rolle's theorem. We're just going to do one of these real quick because Rolle's theorem is just a very specific case of mean value theorem. You don't even need to know the name Rolle's theorem for our AP exam. We also won't throw the word Rolle's theorem at you. Again, if you understand mean value theorem, then you already understand Rolle's theorem. Rolle's theorem is the very specific case of mean value theorem where the instantaneous rate of change is 0. Or I guess the average rate of change too. The average rate of change is 0. So if I put a question like number 3 in one of our tests, I don't need to say anything about Rolle's theorem. Find the number C guaranteed by, I could say mean value theorem instead, and you should still do the same thing. You should say instantaneous rate of change is equal to average rate of change, but when you do average rate of change, you end up with 0. When the average rate of change is 0, that's just what we call Rolle's theorem. But then it still works out the same way. Solve for this, add the 4, divide the 2, and just that theorem refers to that x value of C. C is the value guaranteed by mean value theorem. So one last one, I would like to graph, because again, I think the graph helps you see what it is we're finding. Okay, so here was that function. So on the right side of my work, I did the slope formula to find out the average rate of change was 0. And because that is the case, you could call this Rolle's theorem instead of mean value theorem, but it's still the exact same thing. It guarantees that there's at least one time when the instantaneous rate of change is equal to the average rate of change. And then the algebra work that we did, we got x equals 2. When x equals 2, that's when the instantaneous rate of change is equal to the average rate of change. 2. Sorry. Okay, I would like you, again, since this is just more mean value theorem, we don't need to do another example, but I would like you to read this question from 2003 AP exam. It was actually on the BC exam, not the AP exam. If you guys are not aware, the BC exam actually has a lot of the same questions that the AP exam does. So look at that table, read the directions there, and then see if you can pick out which one of those answers must be true. And then we'll discuss.
Hey, I remember doing these, but I wasn't able to find the paper in my binder. Could I have another one to...
Yeah, I'll put my extra copies in that basket over there. You see where it says AP calculus handouts against the wall? Yeah. You just need to know the binder number. I think it's 51 maybe. So of course this is also, oh, well, I put the year on there. This is pretty old. Multiple choice questions used to have 5 choices. Now I think they always have 4 choices. But the 4 wrong answers are all basically wrong for the same reason. So you look at this table, answer A says the minimum value from 0 to 4 is 2. Does it look like the smallest value is 2 in this table? 2 is certainly less than 3, 4, 3, or 2. So you think that this is true? It might be true, but it doesn't have to be true. Why is it not guaranteed to be true? It's the smallest y value.
You can't find the critical numbers because they don't give the function. Or
That's true.
There's numbers in between.
Exactly. There's numbers in between. This is a continuous and differentiable function. There's a lot of stuff going on between 0 and 1, and 1 and 2, and 2 and 3, and 3 and 4. We have 5 snapshots of what's going on. You can't assume this is the smallest y value. At 1/2, the y value might be -10, and you just can't see that. They didn't show you that. So for the same reason, at first glance, you think y equals 4 is the biggest y value. It's just the biggest y value that we see, but we're seeing 5 out of an infinite number of points there. Okay, part C, what does this mean?
all the y values are greater than 0.
Okay, and it looks like all the y values are greater than 0, but again, you're not seeing all of the numbers. You're seeing 5 values. So that's not guaranteed to be true. It might be true, but it must be true. What does this mean?
The slope is negative.
Okay, so the slope is negative from 2 to 4. So if we look from 2 to 4, it looks like it's going down 1, and then it's going down 1. So is the slope always negative between 2 and 4? Not necessarily. At 3.5, it might have a y value of 100. It might have gone up real fast and then just back down real fast. We don't know what's going on in between the points. The only correct answer is E, and it should look familiar. Between 0 and 4, there's some number C where the derivative equals 0. Why 0?
Because the slope is 0, the average slope is 0 between 0 and 4.
Okay, so ending y value minus starting y value. So it goes up 0 over a distance of 4. So the average rate of change is 0. They're saying that's equal to the instantaneous rate of change for some value C. And what does that sound like?
Rolle's theorem.
Okay, so yeah, it's more specifically Rolle's theorem, but it's just mean value theorem. But I thought mean value theorem, we don't know what's going on between these points either. So how do we know mean value theorem is still okay?
Because it's continuous and differentiable.
Right, because it's continuous and differentiable, it guarantees that that has to be the case at least one time. So I think that's a good one for y'all to learn from. It must be true. The first 4 sound good. They look fine, but you don't know what's going on between those values. You can't make assumptions there. Okay, and then another good example of mean value theorem, I don't know where this came from, but if you draw a picture with me on this one. You've got 2 stationary patrol cars. You know what a patrol car is? Okay. Equipped with radar, 1.2 miles apart on the street. A truck passes the first patrol car doing 35 miles per hour. 1.5 minutes later, the truck passes a second patrol car. here's the first cop, second cop. That cop measures him at 30 miles per hour. If the speed limit sign was 35 miles per hour, does he get a ticket? The first cop sees him doing 35 miles per hour. The second cop sees him doing 30 miles per hour. Would you expect to get a ticket if this was you?
I feel like you should only get a ticket if you're going more than 10 over.
But this person is going over. And they can prove it. Because how much distance did he travel during this time? Over how much time? Okay, I'm going to change that to hours. So 0.025 hours. So you agree that this represents the average speed, right? The distance over how much time? That is 48 miles per hour. Why does that matter? Okay, I couldn't hear you, but I'm going to assume you said the right thing. If this is the average rate of change, so his speed might be speeding up some, might be slowing down some, might be speeding up some, might be slowing down some, but if the average rate of change is 48 miles per hour, either he did 48 miles per hour the whole time, or sometimes he went faster and sometimes he went slower, but it guarantees that you did faster than 35 miles per hour, right? So they absolutely could give you a ticket. They have proved in court that you went above 35 miles per hour. And so this doesn't say anything about calculus, but what theorem is that? With the mean value theorem, they absolutely could give you a ticket and hold you to it. So, and cop doesn't have to understand calculus to understand this principle. So, and of course, mean value theorem only works on continuous functions, but your car is not just jumping around in time. Your car is continuous, or the path of your car is continuous and differentiable. Your car doesn't go from 30 miles per hour to 5 miles per hour at an instant. It can't have that cusp. So it is continuous and differentiable, so they certainly can prove that you did at least 48 miles per hour. So something to think about when you guys drive around, especially around me. Okay, I need you to have a blank piece of paper, number 52. So we need to get in some practice with these things. So 2 of these relate to class from Tuesday, finding increasing, decreasing intervals, and relative max and mins. That's the first derivative test. You can start with those if you'd like. And then I've got 3 set aside for stuff from today. So 2 on mean value theorem. 1 is the justification. That one you don't really need to do much work for. I think you can probably just reason through those. One of those is finding that C value that is guaranteed by mean value theorem. So you will need some steps in your work for that. That's where you'll need your scratch paper. And then 1 on finding absolute maxes and mins, extreme value theorem. So I don't have a preference in which one. I don't have a preference on which one you start with. As usual, I would suggest you start off with the ones that sound the easiest, to knock those out first. And then of course, if you're not knocking them out quickly, then maybe you don't know it as well as you think you do. So that's also beneficial for you to see. But you have the rest of class to work on this, which is about 50 minutes. 50 minutes for 5 Khan Academies. But what you don't finish, I will need you to do for homework. And of course, on B days, sometimes you guys get extra time for homework, depending on if it's a B week or not. But this week is a B week, so I will see you tomorrow. So if what you don't get done in class, you need to get done before class tomorrow, please.
My computer. Can I use my phone to do it?
Yeah, that's fine.
Okay.
Yeah.
Also, I wasn't here on Tuesday and I didn't do the homework. Can I turn in tomorrow?
Yes.
Okay, thank you.
Huh?
We have a problem. So we're all
Yeah.
in fashion.
Did you know that? If you
And
see
the
photos
day
of
of like
it
the
doesn't fill
thing
out.
for like is the same day as she's on test.
Why?
Is the test short
How
enough
much
that we
time?
could take it and then, cause we have school license that whole day, cause we have to help
Yeah.
set up everything in there.
I'm struggling with
Is
I
the
know
test gonna be short enough?
that,
It's gonna be at least 9 multiple choice and at least 1 FRQ.
okay, so like the whole, probably the whole time, just like last test.
I don't know. Before
Okay. We could take it.
before we were on block schedule, we used to make students do the whole test in 50 minutes.
Oh.
Yeah, you guys are very spoiled on how much time you get. You just don't realize. So I'm not gonna say it's not possible, but it's probably not the best idea because
Okay.
at the very least it would be nice for you to use the last 10, 20, 30 minutes checking your work,
Okay.
retrying questions, stuff like that. But we'll just have to worry about that when it comes. And also those assessment dates, those are always an estimate as well.
Okay.
Like we think, in the past we spent 1 day on this, 1 day on this, 1 day on this, 2 days on, we have a guess, but
Okay.
it is tentative. So it could move up a day, it could get bumped back a day or two, just depends. So I wouldn't worry about it yet. But if you miss, you'll just have to come in during advisory to make it up.
Sounds good.
And I'll make you come in twice so that you just do half of it one time and half another time so you don't feel rushed.
Okay.
Okay, I'm going to put these homework assignments, finish putting these homework assignments in gradebook real quick. And that gives you a few minutes to try some of these questions and then I'll start coming around to help out where you get stuck. Also, when you said y'all are in Fashion Club, who are you speaking of?
Us three.
Oh, all three of you?
Yeah.
And somehow you are all three sitting together? That's weird.
Look at you change
Nope. Nope. That's it.
Of course, you guys may disagree with me, but on these topics, I feel like you have to know more stuff. Know what a critical number is, know when you can use mean value theorem, knowing what mean value theorem says. But the flip side is, usually the algebra and the arithmetic's a little bit easier in these sections. Also, isn't the fashion show during advisory?
Yes, but since we're like a part of the actual fashion show and not just watching it, like we have to go set up like the stage and everything.
The stage.
No,
Isn't it just the PAC?
I wasn't in it last year, so I don't know.
I'm like, I'm the model, so I have to, like,
Yeah.
get me dressed.
Brooke is our model
Yeah,
for the
I
show,
know.
so we have to prepare her.
Well, what if I want to go see the show?
You should. You can come during advisory, or why not just skip the whole day and come you know,
Yeah.
take all your classes down there.
Well, I didn't say anything about that. I'm gonna leave the test for them to do.
Why?
Yeah. And then down here, like, how do I get the X? How do I get that X?
Solve it. I would multiply both sides
By this.
by that and the two, so then you get everything in the
So,
top.
does that mean these twos cancel out?
I'm sure you guys are probably doing these in a bunch of different orders, but when you do the mean value theorem finding C1, some of the questions might have something like between 0 and 4, and then when you do the mean value theorem, there's two values of C that make that true. If one of the values of C is an endpoint, then they don't want you to pick that answer. They want you to pick the one that's between the boundaries. So,
I did it, and I got 2 answers,
okay,
but it says choose an answer. And none of them are the.
go, let me see what you got.
3 squared.
That's good. This part I have no idea about.
Mr. Chamberlain,
Uh-huh.
when I go to the tech office, my like mouse, like on my computer, just like isn't showing up at all. Like I turn it off and on, and then I close it. It's just like
Stop
not.
using a Chromebook.
Just turn it off and back on.
I don't know if they'll be down there.
Would you ever give us this large of numbers to do tests?
Without a calculator?
Yeah.
If we did, it would be like the only one, unless you have time to. I got 7, okay, that looks right. And -5, so minus those.
There was like minus and minus, so that would be plus.
Yeah.
Okay.
Okay, so the average rate of change is -2.
Correct. Then I, so added the 2 over to the other side, and then I did, like, factored out 3, and I got that.
Okay. You did all that, your calculus looks good,
Okay.
but you, right here. 3 times 2 is.
Oh, I see, yeah.
I'm doing something wrong. Like I don't know where to go after this.
Okay, what have you done?
I did like the equation, and like the slope part of this side,
Okay.
and I got 1/3, but I'm not sure what to do.
Okay, well, all of this is the average rate of change.
Mhm.
You still need to set that equal to the instantaneous rate of change,
Okay.
which is gonna be derivative. So you need to take the derivative,
I took the derivative.
okay, but you didn't do change rule. You need to times 3 in there. So, just Google times 3 on that, this should be fine. So this is your instantaneous rate of change. This is your average rate of change. Mean value theorem says that these two have to be equal at least once. So set those two equal to each other and solve your equation.
Okay, thank you. No. But the first time I did that.
Anybody else have a math question or two ready to go?
Terribly.
Yes.
Like the top of the other side by it.
Yeah. Okay, so you have this that you can do this. And then I would multiply like this.
Or this.
Wait.
This. I already multiplied it by the 1/3. Like I multiplied this side by
Oh, okay, I
this
see, I
side.
see. So like, this should be like 9 equals 2 squares of because did you want to get rid of the fraction? So
I was trying to get rid of this fraction.
but like you might as well get rid of this one too.
I got some of those calculators over there you can use.
Cause like on this one,
Okay.
because like I'm on the same step you are right now. Cause you don't want a fraction, so like I multiply this side by cancel, and then I multiply this side by and like it would cancel here, so then it would just be 8 equals 2. And then you have no more.
So I have to multiply
So like to get rid of this 3, right, you have to
Yeah.
multiply both sides by 3.
just like it, but I don't think you.
Yeah,
I have to do it.
oh no, just by 3.
Oh.
Yeah.
Then plug negative 6 the next time. Get cylinder. Subtract those, represent your rise. And then divided by 0 minus negative 6 to get your rise.
It would just be like, oh wait, I think you did it wrong, I don't know if that's like.
Yeah, I think so too. So then I would take the square root of it.
Yeah.
Or it is taking the side square root of it.
I would divide, yeah, you divide it by 2 and then both sides.
Which one is the square?
And then
Just get rid of it.
and then divide by 3.
I don't know if I wrote the original.
Where's the 2 coming from?
Where's this two?
Oh, it was 1/2 times 4.
It's not
Okay,
even
two.
an answer.
And then that's the crazy thing.
Okay.
That, so there's no water.
Maybe you did this wrong, because all this math looks great.
Yeah.
So like, I
And
think
then,
maybe.
Oh, but either way, like, even if I just put
I don't know if I
like.
both talk to
Oh,
you
I
about
would
this.
Then it
get the
wouldn't,
gist
yeah.
of it.
Four x minus 3,
Okay, so you don't have fractions anymore?
Yeah.
That looks fine still?
and then square both sides.
Square both sides?
Where did the
Okay.
finish
And
27,
then
right?
the 4 minus 3 equals 1.
1 minus 2. Dude, all you have to do is talk it out and then you see it yourself.
So I'm doing this,
Okay.
and it's not.
What about, you dealt with this part too?
Mm-hmm.
I don't know. I can throw some of the numbers in the calculator, but.
Yeah.
I can, let me finish this one.
Okay, that looks fine. 13 minus 4 would be 9, so I'm good with this being 1/3. So that's, you put that here?
Yes.
Okay. And then chain rule, bring the power down, lower the power by 1, multiply by 3. Okay, that looks fine too.
And then this, all of this, to get rid of this fraction.
Yeah, you basically cross multiply.
And then square this.
Okay.
And change it.
Right,
Divide by 2.
Give me, just, give me your original problem.
No, okay, so I have boxes.
Okay, the one thing, I don't know if this is it, but see how this is screwed to all of this?
That's what I have.
Yeah. May drag that a little bit further, that bothers me. So, 9/2, be 4.5, square both sides, add the 3 over, divide both sides by 3, and I get an answer that's listed there.
I'll just try my math.
Okay, so that's that. You still need to add the 3 over, and then divide both sides by 3. You must have just hit an above wrong or something. Did you have something I can help with, or?
Do you wanna?
Oh, yeah.
You can do this?
What?
Okay.
Yeah, here's the question, sorry, I just
Getting
like.
the math right, and I just don't know what I'm doing wrong.
Good, looks fine.
Wait, am I on the same question as you?
You might be fixing it for you.
0 to 3.
Yes, seriously.
Okay, I think I'm with you
Yeah.
to where you're at.
Okay.
Okay, but we need to finish solving this.
Okay.
So, you can try to set this factor equal to 0, but 3 doesn't equal 0, so
Yeah.
that doesn't give us an answer.
Alright.
To know where the rest of that equals 0, you need to try to factor what's left behind too.
Yeah, that's what I was having trouble with. Isn't it when we're supposed to 5 and that's like?
Yeah, since A is 1 in there, yeah, you can do it that way.
Okay, and then I could, I mean, it would just be 5 and 1. Like, I didn't know.
Oh, wait. I see what you're saying.
Like, that's where I got stuck.
To factor this, you either need a +5 and a +1, which doesn't give you 4, or a -5 and a -1, which doesn't give you
Yeah.
4.
So I didn't know.
Incredible, incredible.
Wait, let me look from again. Maybe I too quickly. Okay,
Is
yeah,
that
it's
3x
with your
plus
slope
18x?
formula.
Okay.
So you have two things. So on the top, you plug in x equals what first?
X equals. Oh, wait.
And then next you plug in x equals 3.
It's the other way around.
Well, no, you can do it that way, but you've got to be consistent in the denominator. You did 0 and then 3, and then on the bottom you did 3 and then 0.
Okay.
So you just need to be
Bottom of
consistent.
it and,
So
like,
that's going to change that sign, which will change that number and
refreshed
everything
it,
else.
did a bunch of just stuff.
That help? It did help?
Yeah. He like took the bottom of this off and like, I don't know, did a bunch of tech stuff.
Of course, as you guys practice this, one thing I'm hoping you get out of it is a little bit of practice with these new things and making sure you know how these theorems work and how to approach the questions and all of that kind of stuff. But also, just like everything else in here, it's good for y'all to have to practice the arithmetic, some factoring, some solving equations, all of that kind of stuff. And those are easy to make mistakes on. But you guys know, part of what I like about the Khan Academy is it's a little bit higher stakes. It forces you guys to slow down and really, really try to avoid those careless mistakes. If you don't make a conscious effort to try to reduce those, then you're still gonna just make as many small mistakes at the end of the year as you do at the start of the year.
I think those are on. The
Oh,
answers.
those ones.
Mr. Thompson, I swear I did everything right, but does this factor?
I don't know. I have to
Is
try
there
it.
like a thing in the calculator that does it for you?
Factor?
Equation solver?
No, that doesn't solve it for you.
Wow.
What do you have? 3x squared
Minus 4x plus
plus what?
5.
Okay.
So it's like what multiplies to 15 and adds to -4. Is that the way you think of it?
That's
Or is it
That-
backwards? Is that backwards?
that's part of what you can do if you can't get it with guess and check.
Bookmarks and like all
This
the
time
lines
this
saying
needs to be 3x
stuff.
squared, so probably one what?
About to die.
That's good.
Yeah.
That's, so I got an A on both, but
X.
Okay, so that's a reasonable guess.
Yeah.
This times this has to be positive 5. So what could multiply positive 5?
1 times 5.
Okay, so throw in 1 and 5.
3x
So
squared.
this is good, this is good. But when we FOIL this, we get 15x plus 1x, which is 16x. Is that what we want?
No.
Okay, then this can't be right.
Okay.
So 3x times x is probably good. What's a different way to multiply to get 5?
To get 5.
Yeah. How about -1 and -5?
Okay.
Okay, now you get minus 15x minus 1x, which is minus 16x. Okay, so what else could we try? Because of this 3 is what complicates things. Because whatever you put out here in FOIL, this gets multiplied by 3x, and whenever you put here, it only gets multiplied by 1. Yeah, so maybe try the minus 5 here, and the minus 1 here. Now you got,
So this makes me think I did something wrong previously, but I checked all my work again and I got the same numbers.
this is minus 12x.
Yes.
Let's check your other
No,
one.
it's not, never mind.
Huh?
It's 18. My bad.
But what you were referring to is product sum. So like, this won't factor.
Uh-huh.
So I usually feel pretty confident after I do guess and check for a while. But what you were referring to is A times C being 15, B being -12. You can rewrite this question. That doesn't mean your answer is a 3x minus 12 and an x plus 15.
Uh-huh.
You can rewrite the question to be minus 12 of these, plus 15 of these,
have to do like the GCF out of each one.
Like, what am I doing? That doesn't
But I
make
know what
sense.
you're saying,
You need two numbers that multiply to this, but add up to this.
yes.
So 1 and 15, no. 3 and 5, no. -1 and -15, no. -3 and -5, no. And since I thought everything that multiplies to this, none of them add to that, I could say for confidence now. it's fine
Okay,
with that.
okay.
But in theory, if you got this isn't your answer. This rewrites it where you can do factor by grouping.
Yes.
And factor by grouping is guaranteed to work
Okay.
if you can make the right substitution.
Okay.
How do I find, like, I'm getting a fraction on this side.
Okay.
So if I were to like solve for it, I would have a quadratic with a fraction. How do I solve that?
Well, assuming that this part's right, this would be 13, and then if you subtract the fourth, that would be 12 and 3/4.
Mm-hmm.
What was the other part?
Plus 18x plus 3x squared.
Okay, and now that equals 0.
Mm-hmm.
Well, we could change this to be 48 plus 3 this is 51/4. One thing you could do is you could just multiply everything by 4. Times 2 would be 36.
72.
Okay, 72. And then the reason why doing math would be nice is 0 times 4 is still 0, and 51/4 times 4 would be 51. Makes these numbers a little bit bigger, but you're at least not dealing with a fraction. But I didn't check the work before that, so I can't.
Even like the -18 is still does not.
Well, I don't know what your rest of your work was. I didn't check any of that.
Oh, okay. Well, I did like twice. I don't know if that means anything.
Okay, what's the equation?
It's like, this is my derivative right here, and this is what I got from.
Probably need an X there.
Yes.
Minus 18.
And then I subtracted the 7.
Okay. Did you check the 7?
Yeah, like twice. Plugged it into the original equation.
I have to do it myself.
No, it's okay.
Okay. I do the storing. I just think that
Okay.
that's quicker because then I only have to type
Yeah.
this mess at once. But okay, so your ending y value is -66. Your
Yep.
starting y value was that.
Mhm.
So -66 minus a -129.
Yeah.
Okay. Over how much?
9.
Okay, so that gives you 7.
Uh-huh.
Okay, that looks fine.
I think I can do it. 3x.
Did you get the one where you just had 2
x plus 7.
Why you put plus 12?
Oh my. I just need to.
I'm not gonna use it. I'll just take the sugar.
Okay.
First one that started with it. But I started with the fourth.
Why? Wait, no way.
It's so sad.
Where's the decreasing? I don't know, did you find the critical numbers? Well, wait, if you plug -1 into the function, you're getting a y value.
It's like
You're,
means less.
that's like you're asking about.
Yes, that was so fun.
You want to know the derivative. You should have plugged that into the derivative.
What do you want?
That's all you have to do in math
I said
ACT
you
score.
started like 2 days ago.
I think you have the highest math ACT score of any of my students this year. At least so far. Okay. Well, what's your highest math score? Oh, I don't know if yours showed up on my list, but we have a program that shows some of that stuff, but. You guys have something else to help with? Good, super. We can just answer it for you, so that's.
Cash.
I feel like 90% of the questions I'm answering today are just like small mistakes. Like plugging in the number wrong, not typing in the calculator correctly. Of course, I'd rather it be that than calculus mistakes, but that's still stuff y'all need to work on.
If I get into Michigan, then I'm gonna apply this. Or I did in Michigan or Indiana, so like I'm really just giving up
I
this.
figured out I had this part wrong. Like I didn't, like I subtracted out and I brought this negative 7. But I still am getting a fraction of what to do with. And then like I don't know how to factor it.
When you put it in the calculator, do you use the store?
Can you honestly make that last week?
So we're going to try to find the y value when x is -1. So I do -1, store into x. And then, so now when I hit x, my calculator knows that's -1. So I don't have to worry about these parentheses as much.
Then
Okay.
you just hit store again and save it as the thing.
Yeah, and so then next I'm going to try -7. So now I have to store -7. Second enter pulls up the last thing you typed in. Second enter pulls up the thing you did before that. So 7 the second time. So -5 minus 7 was that 2? It would be -12. So then that whole side should be -2.
I really did like 5 times. I don't know how I got that.
Well, again, when you typed it in, you need parentheses all those times.
How do you store it?
So you have to type in the number first, then the store, and then the letter you want to store it in for.
Okay. How do I like change the letters there?
What do you mean change?
Like if I had more than one, or would I just do a different one every time?
Yeah, so like if you wanted to store something in for time, you might like do an alpha T, and you could sort it in for T. I just use X just because it's quick. There's a button ready for X.
How did you go to like a second, like you said second enter for the second?
You see how
Oh,
in
okay.
blue it says entry?
Uh-huh.
So that pulls up the last thing, and then you can just keep spamming second enter, second enter, second enter, second enter. and
Okay.
It keeps pulling up the,
The last thing.
I didn't mean to do that 4 times. But it keeps pulling up the stuff that you've done in the past.
Okay.
I know y'all can do this, that works too,
Yeah,
but
okay, thank you.
I don't know if it multiplies 33 and adds to 18.
Well, I don't know that you need to do product sum there. I think you could probably get that factoring with guessing. You have 3x squared, which is probably going to be a 3x times an x. Right? And then what do you have in the middle?
18.
And then
I'll do
11.
plus? Yes. Okay. Well, this times this means to give 11. So what times what gives you 11?
11 is 9.
Okay. So we could try to put 1 here and 11 here. So far this is good and this is good. But the outer part of FOIL would be 33x. The inner part of FOIL would be 1x, which would give you 34x's, not 18x's. But then you could just try something different. You could just maybe put the 11 here and the 1 there. That doesn't mess this up. Now I've got 3x's plus 11x's, that would be 14x's. You need it to be 18x's. So either this doesn't factor or we have a mistake somewhere else. So let me look at the rest of it.
Two more? Or you just said two in total? Two minus
Why,
one.
okay, so this was plus 13. I agree with that, that's part of the derivative. Why did it change to a plus 11?
And then subtract the 2.
Okay, and we were on the same page between the two, right? Well, and this was a positive 2, not a negative 2? I just don't remember.
Sorry.
Oh, no, that's fine, that's. Okay, now you could also factor out 3 too, if you wanna make the factoring a little easier. But it looks like you're gonna get 2 answers. I guess one of the answers is gonna be either -1 or -7, and don't include the endpoint, and then the other one's gonna be somewhere here. I will come check back up.
I'm on my like phone. I get this wrong actually.
Oh, wait, did you get the copy of X of like just 12X just the reasons?
No.
Oh.
So one of them is
I guess I will say, if you notice that you're making lots of arithmetic mistakes, try to make your handwriting look a little better, try to organize your work a little bit better, where it goes from one line to the next line to the next line. That does help a little bit. Do I have any that I can help with?
It's also now just like not letting me log into Khan Academy. Some success, but since like they all do tomorrow, let me see if this works, and then if it doesn't work.
Okay, you might have to go ask them again, I don't know.
Okay.
You can also do it on your phone, I mean.
Oh, real? Oh, real? Okay, that's not true.
What?
So I think I've done everything right, but you know, my answer is it's just stopped it.
Okay, well then, that can't
I
be.
don't wanna make you have to do it all.
You didn't do chain rule on your group.
Also, I can't do it tonight because I work until like 11. So, we'll see.
Do I have anything I can help with?
Last minute I started. I didn't do it.
Oh, let's go.
Let me know if you need. No, that's it, you have nothing to lose, this is from. Okay, I can try to do it. I'm just gonna do an extra word so I can. Did you do chain rule?
Nope.
So everything you have is probably right, but instead of just doing 1 over 2, it should be 2.
One or two. It should be
Like,
like,
when you did, like, the took the derivative, right? So then it brings this to the denominator, but when you multiply it, like, do the chain rule, it would be multiplied by 2. So there should be like a 2 at the top.
oh, okay.
Like, this is all the work.
Because of the chain rule. Because if you take the derivative of the inside, it's 2.
You're
You know,
right.
so, like, I think
Thank you.
I don't know, it's like,
I love Wait, so
What chapters was it closer to? 6
Oh,
through 18?
no,
What?
Of course, if you really get stuck on one, you might just want to skip it and do it at the end. You don't have to stick with the same one to move on. Some of these are definitely easier than others. The finding C and mean value theorem is probably the one that requires the most work. Which will have the most mistakes in it.
I hope it comes back to me. I mean, I did read it, but like, it really was such a long time.
That's in 2 hours.
I think it's 70 sort of.
The project review, is it 150 words per response or is it in totality?
First, what she said, she said, I said 103 words because I didn't put the word count, people wouldn't care. So like if it's not 100 words, it's fine. So like a good response.
Because I was looking at the example and then I found that each yeah, it's.
All right, guys, we're down to about 4 minutes. So make sure that you jot down that you need to work on finishing this up. Of course, advisory would be a great time to do that if you don't have something else going on. And I will see you again in the morning since this is a B week. But we will need to move on to second derivative test. So make sure you're getting the practice in that you need to so that you don't feel like you're falling behind here.
What is it? In the mix?
Are you sure it's not real?
I'm gonna keep it close. And it's, you know, like, friends, not now, when you
Which one?